So we don't forget videoing, mate.
Videoing. Reading.
I'm waiting.
Waiting. Waiting. Waiting. Waiting.
Waiting.
Waiting. Waiting.
Connect your charger.
Minto lang, marami pa na.
Alright, so if we get a quick coaxial cable, I think I might have to make that assignment a little bit easier. It might be too difficult for some of them. Right, here you are, quick coaxial cable. Yeah, put it in there. Alright, write this down. You press the variable sometimes here. Alright, now, right, let me just set this up. I'm going to just set a 1 kilohertz signal, just out of interest. That's about 1 kilohertz. Suppose I didn't know that was 1 kilohertz and I wanted to measure it. Let's put a sine wave. Yeah? Now,
You guys videoing it.
yeah? What you have to do is, that's set. That's producing a signal. Ooh. Ooh.
Ooh.
What's wrong?
That's producing a signal, sine wave. And I want
You're
to
gonna regret
measure.
that, Merritt.
I want to measure that signal. What I have to do is use the oscilloscope. That is a measuring instrument.
Right.
Yeah?
Then.
Then it visually displays it. Now, as it stands, it might be a little bit, I have to count the number of squares, yeah? So the best thing to do is put it on a setting that's easy to read. This knob here, as long as you make sure, it's important that you make sure you press the ver button in, so push that in so that it's calibrated. Push that in so that it's calibrated, yeah? Now, I want to measure the amplitude. It's AC. Yeah, so put it on AC first, yeah? If you're not sure where the center line is, put it on ground. And there it is. And then you can move that up till it's in the center.
How can
Yeah.
you see it stand up? You're so lazy.
Okay.
How about this one?
Now, which one?
Oh, I can see that.
Yeah, that one, that big one.
That's for triggering. That's for triggering. That's the important one. I'll show you that one in a minute. Yeah. Now, you can put it on AC you want. That's the triggering. Triggering just means you want the wave to remain still and not move around. So you trigger it. Put it back on AC. Sorry, put it back on AC now. There it is. That's the signal that's going into it. Now, I want to work out what the amplitude of that signal is. Ideally, you should take the reading between those dotted lines, yeah?
Yeah.
See those dotted lines?
Yeah.
Where it says 100% and 0%? Ideally, don't have to. Yeah? Right. So now, this is on 1 volt per division. Yeah? Each division from here to here is worth 1 volt. So I count 1, 2, and if you look at the increment, let's move that over a little bit. In the X position, that gives you, moves it back and forth, X. The reason I've lined that up with the center line is so I can read those minor increments. Yeah, the major ones are the big ones, these are the minor ones. Each one of those, that's worth about, each one of those is worth 0.2 because it's broken into 5. Yes? Okay. So it's worth about 0.2. So that's 1, 2, and about 2.2. I'll give that 0.2. It doesn't quite get it. Yeah? So that's 2.2. 2.2 squares multiplied by 1 means it's 2.2 volts you're reading. So you take the number of squares multiplied by the setting on here.
That's for volt peak.
That is for volt peak. Well done. Yeah? Now, peak to peak is just twice that.
So it's twice
Or
that.
if you wanted to measure it, you could count from here up to there. Yeah? So you could count the whole squares, 1, 2, 3, 4, and this is like half a square. Yeah? And that's like 0.2. Yeah, so it's about 4.5, 4.7. That's where some people read one and some people read another. But take that value, 4.5 or whatever, more times that, and you'll get the peak.
4.5 volts.
Yes.
What did I say? Kilo. That's the peak.
That's the peak to peak. But the easy way is to take that value and double it. Yeah. You can if you sometimes up it, but then it's gone outside the range. You can't use it. Yeah. Now, if you want to measure the periodic time, how long a cycle lasts, you can use this to line up, say, the start. So if I line it up so I've got the start there, yeah, and I can count the squares this way in the horizontal. 1, 2. So that last 2 squares, and each square is worth 5. Hang on. 0.5. Can't sit in my glasses, so my vision is getting worse. 0.5 of a millisecond. Yeah? Each square is 0.5 of a millisecond, so that's 1, 2 multiplied by 0.5. That's 1 millisecond. Yeah? 1 over t gives you the frequency. So 1 over 1 millisecond gives you 1 kilohertz.
Yeah, so 2 times 0.5 is the
is a periodic time. Right.
Okay.
Now, it's not very convenient to measure that as it is. So in reality, what we do is we expand it. Now, if we close it up, you can see that's not bad if you want to measure height that way, but it's not much good if you want to measure in between. So we expand it so it's a bit easier. Now that is a lot easier.
Yeah.
And then I can find the start. The start is about there, and I can measure, or I can go about 1. That's better, isn't it? 2, yeah, so I can say, all right, there's the start. 1, 2, 3, 4, 5 squares. Much more accurate. Yeah? 5 times 0.2 is 2 times 5 is
10.
what is?
What
Is 10, but that's 0.2, so it's 1. Yeah, 1 milli. You must remember that setting there, which says 1 milli. So that is 1 millisecond periodic time. 1 over 1 millisecond is 1 kilohertz.
Okay.
Yeah,
Okay.
that's it. Do you want me to set one up and you try, or you want to?
No, just
That's enough for now.
That's enough for now.
All
That's
right.
enough.
Okay.